So we have a set of data and we want to find a math model. So what I'm going to do is highlight the data. Here I have position and time data, and I'm going to scroll back to the top before I insert my chart. That way my chart will be up here where I can see the top of my data table. So I'm going to go to Insert Chart. And I think you can immediately see that this chart follows a pattern which is somewhat familiar to you. It looks like a sine wave. And so our job is going to be to figure out how do we transform a sine wave to fit this function here. Okay? So to do that, let's quickly review sine waves and their transformations. The basic sine wave looks like this. It starts at 0, 0. It goes up to 1, back down to -1, and then back to where it started. So if it starts at 0, it gets back to 0. And it takes 2 pi units of time to get there. Okay? So we can transform a sine function. It looks like this up here. We can take the sine of x, and we can multiply the inside by b. We can subtract c from it. We can add d to it, and we can multiply it by a. So the thing that we just need to review is, what do all of these things do? What does a, b, c, and d do? So you may remember that transformations that are applied outside the function, so a and d, affect it vertically, and transformations applied inside the function, like b and c, affect it horizontally. So let's look at D first, because D is the easy one. D is a simple vertical translation. So making D bigger moves it up, making D smaller moves it down. So the entire sine function normally oscillates around the line y equals 0. So it goes up 1, down 1, up 1, down 1. It's oscillating around y equals 0. So if I make D 2, for example, it'll oscillate around the line y equal 2 instead of y equals 0. So that's a vertical transformation. So I'm going to put that back to 0 now. On the other hand, c is inside the function, and so it affects it left and right. So if I move c so that c gets bigger, it moves to the right. And if I make c smaller, it moves to the left. So we're looking at this sine function sliding to the left and sliding to the right. Okay? A is outside the function, so it affects it vertically. So making a bigger doesn't change the period. It still crosses at 0 and back at 2 pi, but now it goes up to, let's make it 4, a nice even number. Now instead of going up to 1 and down to -1, it goes up to 4 and down to -4. So we call A the amplitude of the sine function. It's a vertical scale factor. And let's put that back at 1. And if A gets smaller, then of course it shrinks it, right? And then the last thing is B, and B is inside the sine function, so it affects it horizontally. So here's where it gets a little tricky. If I make B bigger, it actually squishes the sine function. So as B gets bigger, the sine function gets compressed, and as B gets smaller, the sine function gets stretched out. Okay, so we are going to try to fit our graph with a function that looks like this. So here is our data. We need to find A, B, C, and D so that we can properly transform a sine function to fit our data. So here's what we're going to do. We're going to find the parameters A, B, C, and D. And we are going to calculate the value of the sine function for various values of A, B, C, and D. So I'm just going to put in 1, 1, 0, 0 for my initial values. And I'm going to calculate a model. So this is a math model, okay? So to find our math model, it's going to equal A, so that's B1, times the sine of B times, another set of parentheses, my value of x, which is right here, the time, minus C, which is right there. I need to close 2 sets of parentheses, and then I have to add D. Okay? And now I'm going to copy these down, but I'm going to have a problem because some of the references shouldn't be changed. Anything that references one of these values shouldn't change. So it's a little hard to see here, but my B1, my B2, my B3, and all references to B4 should not change when they're copied. So I put $signs in front of them. The only one that should change is A8. So what I can do is now drag this down, and that will calculate the value of the function for these parameters of the model. Now, to help see that, I'm going to redraw my graph. So I'm going to do this again, highlight all 3 rows. The first row is X, the next 2 are Y. They're series. I'm going to insert a chart. And assuming I can find chart, I've got to make sure it's a scatter plot. It is. And so it looks good. So I'm going to go ahead and close this dialog box here. So here's what we're looking at. The blue dots are my data from my harmonic oscillator, my pendulum or my mass on a spring or whatever. I've got to tweak these values of A, B, C, and D until the model, which is the red line, matches the blue line, which is the data. Okay? So the first thing you might realize is this goes up to 1 and down to -1, and that's way too big. My actual function only goes up and down a little bit. So I'm going to tweak A and make that more like 0.5. Okay? So it's a little confusing, but if you notice, it wasn't actually the data, the position data that moved. The model just got shorter. Now, I need to move my model up a little bit. This looks like it's oscillating somewhere around between 0.5 and 0.3, so I'm going to make this 0.4. That's my guess. And I need to make it a little smaller again, so instead of 0.5, let's try 0.2. And I need to make it oscillate more. I need to horizontally compress it, so I need to make B a little bigger. So let's try B of 2. Okay, so we're getting closer now. So I'm just going to keep tweaking this, make it a little smaller, so 0.15 maybe. It needs to be compressed a little bit more, so instead of 2, let's go with 3. That's getting much closer. In fact, that's a little too much, so let's go 0. I'm sorry, that was 3, so let's go 2.8 maybe. I'm just kind of guessing here. It's still guess and check. I need to move my model down a little bit. So instead of 0.4, let's go 0.35. And now we're getting really close. You can see we're starting to figure out the parameters which describe our blue data, and it's shown by the model. Now, before I go much farther, I'm just going to tweak it a little bit because we don't show math models as data points. Okay, so I'm going to edit my graph here. And for my math model, so I'm going to go down here to Customize. And on Series, for my math model, I'm not going to use any points. So I'm going to go to None on Point Size. And I'm going to connect them with simply a thin line. And the best way to get a thin line is to go to Trend Line and choose Moving Average. Okay? So that's probably about the best way we can get it to show as a thin line. On Excel, you can show the line that connects them, but in Google Sheets, you can't. So that's what we're looking for there. That's going to be red, and that's totally fine. So there we go. All right, so now my math model is this thin red line, and I'm going to keep tweaking it. So I need to stretch it a tiny bit horizontally. So instead of 2.8, let's go 2.7. And let's shift it a little bit to the left. So that is C. So instead of 0, let's shift it. This peak is right about here at 0.5. This peak is about 0.7. Let's shift it about 0.2 or so. And that moved it to the right. So I've got to make this negative to shift it to the left. Okay. And then just maybe make it a little bit shorter, 0.145. 0.14 maybe. And so you can, 1.4. So you can see that by understanding how functions work and transforming functions and tweaking these parameters, we can pretty quickly arrive at a math model. Mine matches pretty good here, and it falls a little, I just need to stretch it horizontally just a hair. So instead of 2.7, I'm going to make this 2.6. And maybe 2.25 there. So there we go. That's a pretty darn good math model. Okay? So now the last thing I need to do is clean up my graph. And so I'm going to go to the dialog editor here. Under Customize, on the chart title and axis, the chart title is the relationship between position and time for a swinging pendulum, or whatever the context is. So you can put that in. Okay? On the horizontal axis, we have time. On the vertical axis, we have the position in meters. So I can put that on there. And then I want be able to put my math model in. So if I go to series, again, we're here on apply to all series. I'm just going to go to my math model. I've already chosen a trend line. So under the label, I'm going to use custom. And I'm going to write the function here that describes the position. So the position x is a function of t, and it equals a, which is 0.14, times the sine of b, which is 2.6, times the time, that's x, minus 0.25, and then that's all plus 0.350. So I'm basically typing in this math model, okay, and that shows up right here as the function. And then you can scroll down to legend here, and you can move that around a little bit. So maybe you can put it inside your graph. It goes there. We can make it a little bigger since it's super important. These words position and model come from the labels right here. So you can't change those. I suppose you could delete the word model and it'll go away there. And then the last thing I want to do, I want to be able to see my math model. Right now it's over my data. So I'm just going to adjust my y-axis. So under customize in the vertical axis, I can make my y-axis go from 0, for example, up to 0.7. 0.7. And that just gives me enough room so that I can actually see my math model. I can see the data I collected, and I can see the trend line which fits it. So there you go. That's how you can use a spreadsheet to find the math model using sort of rudimentary knowledge of function transformation and maybe a little bit of guess and check. Okay? So that's what you're going to do for your data sets that you collected for the math on a spring and for the pendulum. So for both those data sets, which you collected yesterday in class, you're going to try to find a math model, and then this is the graph you're going to export. Okay? So you're just going to go to here, go to download, PDF, and that's what you're going to turn in, one for each of the two, math on a spring and the pendulum. All right, good luck.